Yeah, so here's the setup. You can see the 4 sensors. The way I wrote the code right now is like if you're on this side, it's gonna go left. If you're on that side, it's gonna go right. Similarly here, over here, it's gonna go up. There's down. It was supposed to be like, you know, if you're doing this motion, it's like this gets triggered, then that. This gets triggered, then that. You would flip that so it goes downwards, but I gotta think about that more. This is the simplest way code I could write, you know, like in an hour or whatever. But and then this is the clicks, like turn the trackpad on and off so when you're typing it doesn't trigger it. That light turns on, and then left and right click. You can see like if you can click that. Where's the mouse? Over there. Click. Oh, it's over there. Yeah. Click that. Oh, I'm zoomed in. My bad. Yeah. So this is using pyautogui. So a user had suggested or asked, what if you put the sensors along the keyboard? Which at first I was like, you know, I don't really like see it. But now, see, this project is supposed to be like a cyber deck using this screen, which is pretty massive. I don't know how big it is. I need like a, it's hard to use with one hand. Let's see. This thing is 14.5 inches long. Damn. But you can see this keyboard almost is the same length. And how this freaking trackpad doesn't make sense. It's too damn big. So yeah, I'm gonna try it. I'm gonna try and set up a trackpad above this. It'd be like one sensor here, one sensor here, one here, one here. So then your motions like that. And then the clicks, you could just do, you know, like a hit control and a key, left click, right click. I also can add like physical buttons somewhere. I don't know, because I have this space. This thing has to become like a solid piece. But yeah, so I'm gonna try that out. So I got more of the sensors. It's so funny working here. Become part of the hive. Whore. There we go. Sorry it's dark. I got the f-stop way open. Or closed rather. So yeah, a bunch of these. Not a bunch, 4. Like one here, one there, one there, and one there. And then that's 4 like intersection points or like different sensors. So going downwards, the 2 on the side are what's being measured or detecting the down. So what I have to do is like design a very minimal plastic usage clip that goes under this. It's not the final design, it's just like something to work with. It'll just be like a flat like frame, you know, think of like tic-tac-toe kind of shape. And then it'll go up and hold the sensors based on this thing's dimensions. So when you're working on a hardware project, you gotta get yourself one of these. Yeah, so you measure this, that gives you your dimensions, and then you have to have a tolerance because it can't be the same, you know, dimension or else it won't fit. Alright, so see, so here You see a model of how this thing would work. That's like a chunk of the side of the keyboard. It's just an abstraction, like the main dimensions. But yeah, so look at it top view. You know, if you wanted to like mouse down, go left, what's happening is you're breaking like this beam and this beam. You go downwards. So this one fires, then this one, it means you're going that way. Alright, so this is what we've got. This is an L shape, but it was faster to print it split. It was like 3 hours versus 1 because of the supports. That's what those little corner things are over there. These 45-degree angle things here, you join them together and that's brackets. This is just a temporary test bed. I'll probably end up printing like a temporary holder for the 3 buttons, but I just need something physical to work with as far as programming. Here it is printing. Oh, here it is. Unfortunately there was like warping. Is it printed flat? Yeah, you can see it. It's worse on this side, but yeah. The Council of Senses has gathered. The other design I was thinking about is a channel, like a X and Y channel. But then you'd have to like either use 2 fingers or like go this way then this way. That would be brutal to use. Alright, so I've got it wired up. That is a lot of wires. Let me get it in better light. See how it works. It's about to fall off. It's just held on by double-sided tape. So now that it's all wired up, I can program it. What I'll do is write code that can move a box on the screen by doing this. Alright, so I made this here. This is just a board, basic board. Left side, when you click it, it enables the sensors, so it's like you're in trackpad mode. That way you can still type. Which these things are kind of in the way, they'll have to back those away. But then when you click that, the red light goes on and says it's active. And these are left and right clicks. Really not ergonomic, but sorry about the lighting. And there's a resistor here. If you flip it over, these buttons, like, they take a power rail from the Raspberry Pi, like I'll take 3.3 volts, goes through a resistor to limit the current. Click a button, it allows it to flow into a GPIO. When the GPIO detects that, that's a high, GPIO high means it's on. And then there's another resistor that powers this LED. So this is the setup here. Get the Pi 4 over here. The keyboard is wirelessly plugged in, but it can be through Bluetooth. But what I was trying to show is this is the display, right? This is the Raspberry Pi OS. So HDMI is coming out of here, connected to there. There's the cursor, which right now I can't move, but I can with, or I will be able to with this thing and Pi Auto GUI. Alright, so I've got them all wired, and you can see here, see going through the numbers. See if I can focus that. And if I go through like, so the way I put it in code is like this is top left, top right, side top, side bottom, SB. So if I go like that one at a time. You'll see it over here. Like top left goes to like nothing, 0. Top right goes to like 0 or 1. And then right is also like 0. Oh crap, something's wrong with 0. Dang. Alright, so here you can see the LED turn on and off for 2 seconds. That's what will happen with the click here when it's active. God, my knuckle looks gross. It's a blister from working. Okay, so I wrote some code to address these buttons. So there's a loop going. I can click the trackpad. That's this one here. I can show them in the same frame. Then we got left click over here. Click that, left click, right click. That's just these buttons here. So I just gotta make like a state manager thing that keeps track of everything, and then as you like go top to bottom, it has like it adds to the Y value, which is based on top left is 0. If you think of a rectangle, top left corner is 0, 0. And I already tested the pyautogui. It picks up the connected screen resolution and mouse position. So one bad news, pyautogui does not work with Bookworm. I'm reading around and it says switch from Wayland to X11. It seems like I was already using X11, so I don't know, I'm gonna keep poking around with that. But so here you should be able to see the cursor. It's all on the right. I'm gonna bring it back to the left and up. Look at it zigzagging across the screen. This is really bad. That's because the increments are 50%. Alright, go left. Going down. If you stop, it should stop moving. Yeah. Get the right click. Bring it up. I'm going to point it to the person's head there. Wait. Right. And then go up. Right. Oh, up, back. Oh. Damn. Oh man, why is there a freaking car squealing when I'm recording? Wanted to provide a quick overview of how this thing works, mostly on the code side, but wiring is pretty much the same as this one. It's just there's a fourth one now. But yeah, all the sensors are connected to the same I2C bus, and they use the sensor shutdown pin. They're all turned off, and you bring one on at a time and give them an address. And normally when you write, good code, it's separated, by context. This one, I wrote it all in one file. It's not great, but yeah, so you bring in the library, which you need. This right here is for pyautogui. As you can see the comment, this assumes you have one display. If you don't have that, there's an error that's thrown. This uses threading, so loops can run inside of another main process, so it doesn't block. For example, well, you'll see down there the buttons are using a thread, so they can run while the sensors are running. Bring in pyautogui, GPIO. Here I set all these pins. I use these 3 for 3 of the sensors, and then I use one, I think, here. Then I use these pins. I also use this one. I use a lot of pins. You can see which ones are used here. 22, 17, 27. That's those three right there. We got 10, 9, 26, 6, 5. What was it again? 10, 9, 26, 5. 10, 9, 26, 6, 5. Yeah, so those ones. So you set all those, and then LED pin is GPIO out. It means you can set it high or low. 3.3 volts with the resistor. This, you need that when the mouse goes near the edges. I could not get that to not throw an error, even being like 300 pixels away from the edge of a screen. So I was like, alright, forget it, I'll just set it. And this, every time the program runs, it sets the mouse somewhere, you know where it is. This is technically bad right here. This should run above this. I'll fix that. But anyway, yeah, then this is the mouse increment. Every like up command or left, right, down command, it moves the cursor 50 pixels. There isn't any like proportionality, you know, like a RC transmitter controller. Like you go really far to the right, it goes fast. Go right slightly, it goes slowly. It's not like that. Basic commands: turn the LED on, off, turn it off, set up the sensors. This is what gives them an address, despite all being on the same I2C address. The sensors are the same, so they all have the same address, 29. They use the same bus. This is the one that's enabled by default. And then, yeah, so you turn them all off. Set their pins as like on, off. Set them all to off. And then you turn one on at a time and give them an address. This, I don't really actually understand how this works, but that's how the library's demo code is working. I mean, I understand what it's doing in code. What I don't understand is if they're all on the same line and you turn them on one at a time, like, what is that? Is that like a matrix, like a keyboard, or... Anyway, rest assured it works. They work isolated. When you finally turn them on to start ranging, you specify like which one is which. And as I mentioned earlier, like I addressed them as like top left, top right, side top, side bottom. That's what the ST, SB. So you call that function, turns them all on. These are the buttons. They're all set like pull down. And then when you give them a high signal, that turns them on. This is the loop that listens to the buttons when you click them. Here's that thread I was talking about. So this loop runs, and then if it detects a high on those values, it does the commands. There's a short, so I turned this off, but like when you turn there's a problem. That's why I turned this code off. I think it's a short though. Like when you turn the LED on, it also keeps this thing on. So it's like a double click. It turns itself off. It's annoying. It doesn't matter. This is, I think, a one-off project because it's not like ergonomic, you know. 2 inches, you know, freedom units. Because I can't think in kilometers. But anyway, our meters, centimeters, millimeters, all that. I'm still sampling. I was doing 10, but I just dropped that down to 3. And then the move mouse, these are all based on pyautogui. So this is like, this is subtracting, so you're trying to avoid setting it. Well, here it's not allowing you to set to 0 actually, which technically is bad. Like you couldn't reach the corner. But yes, these are just boundaries. You know, so it's like if you're within bounds, allow it, go to the new position. Check mouse direction. It's using averages, and then this is what I was talking about with the layout. I don't have like a picture. Okay, yeah, so let me pull this up. If you're looking at this code, D1 greater than 0 means it's not empty. Trackpad max. Trackpad max, that's it's set to 6 inches in here, so if there's no finger in this area, then they measure like 15 inches or 6 or 8 or whatever. So like if the average is below that, then there's a finger in the way, so then it calls it. And I was mentioning like the way this works is like if you want to turn left, you block this sensor. Go right, block this sensor, but you're also going to block these ones. So if you block that one, you're going to go up to the right. Block that one, you're going to go down to the right. If you want to just move one axis, you have to be like directly in the middle, like put your finger right here between these two and in line with this one. Then you'll only go up. Put it here, you'll only go down. But this beam spreads out, so at some point it will hit your finger and trigger a turn. The same thing for turning. Put it like exactly right here, then it'll just turn left and not go up or down. But yeah, so yeah, it's just averaging that calls that. That's what fires off the motions. And then you can see here like the button clicks for pyautogui. Yeah, the actual mouse move is this. So this is a XY coordinate system.